Awesome. So hi everyone, my name is Brian O'Connor. I'm with the Open Networking Foundation, and I'm currently the lead of the Stratum project. And today I'll be presenting this Techinar with Max Pudelko, who's a software developer at ONF and also serving on the Stratum TST. So just to walk you through the plan for today, I see some new faces on the webinar, or new names at least on the webinar. So I just wanted to start with a quick one-slide introduction to the project. Then I'm planning to cover the state of Stratum, talk about some of the users and use cases that we've had over the years. And then Max is going to dive in and cover some of the highlights from the most recent Stratum releases. And we'll close with a roadmap, what we plan to do technically and some bigger picture future for Stratum. So with that, let's get started. So it might be helpful for some of you to understand what we mean when we say Stratum. And the easiest way to start is to say that Stratum is an open source, production targeted thin switch OS. Open source, that's probably pretty clear. Production targeted, also clear. But thin is the part that differentiates Stratum from other options that you see when you're choosing a switch OS. And by thin, we really mean that you have to bring your own data plane pipeline and your own control plane apps. So there's no BGP, LACP, routing, trunking, on the box control plane by default when you download a Stratum image. And this is by design. But what you have to do when you take a Stratum image is you pair it with a pipeline, in this case, a P4 program like fabric.p4. You pair it with a controller like Onos. And then you can pair it with a set of routing applications like the Trellis app suite for doing routing of a fabric. And it's with all these pieces, when you pull them together, that you get a complete stack. And what Stratum does is it provides a rich set of programmatic interfaces for you. So we specify the pipeline with P4. This works with both fixed function ASICs as well as newer programmable targets. At runtime, we program the entities that have been described in P4 using the P4 runtime API. And this works for on-the-box control planes, traditional distributed control planes, as well as off-the-box SDN-style control planes. We model the ASIC and the platform configuration using Yang, and we use a set of models called OpenConfig. And then at runtime, we can configure and monitor these models or the state of the data that's represented in these models using GNMI. So in addition to being able to do sets and reads, or writes and reads, we can also set up subscriptions and stream telemetry from the box back to your control plane. So that's Stratum in a nutshell. And now let's take a quick look at sort of the history, and we can cover users and use cases along the way. So back in 2018, we launched the Stratum community and built out an MVP and a set of initial switch targets, hardware targets that we support. Then we spent most of 2019 demonstrating how Stratum can be used and expanding the set of hardware that was supported by the platform. And I want to just, in case you haven't seen these, just do a quick reminder of these use cases. So we started an OCP at March of 2019, where we demonstrated Stratum for the first time in public. And what we did here was we showed a hybrid fabric where we ran Stratum on Tofino switches and we ran OFDPA on Broadcom switches in a multi-stage leaf spine fabric that was controlled by Onos. On the Stratum side, we used P4 runtime to control the data plane, and on the OFDPA side, we used OpenFlow to control the data plane. On the Stratum switches, we were also able to demonstrate for the first time INT, as well as serving in packet gateway, part of the mobile core user plane, offloaded to the fabric switches. Then in ONF Connect of September 2019, we open sourced Stratum, made it available to the broader community for the first time, and had 3 demos to highlight some of Stratum's capabilities. In the context of SIBA, or SDN-enabled broadband access, we used Stratum to offload a piece of the BNG data plane to the fabric. Using Onos, we were able to demonstrate zero-touch provisioning of a Stratum-based switch using its programmatic interfaces. And then in the demo you see on the left here, we demonstrated Stratum running on Tofino and Broadcom-based silicon in an IP-routed leaf-spine fabric for the first time. Then last year at OCP, we demonstrated a data center fabric topology where we had two sites that were separated by long haul fiber. In this particular topology, we used Trellis, ONOS, to control the fabric in the field office and central office. And then we demonstrated that data center interconnect could be achieved using Stratum, running on EdgeCore's Cassini packet optical transponder. So that was a quick look back at some of the use cases that we demonstrated back in 2019. And next, I want to talk about what we've been up to this past year. So this past year, we've largely been working with users to bring Stratum to trials and production. We've taken a pretty significant effort also at improving the usability of the system and improving documentation. And I want to just walk through a few of the users we've been working with. So I'm happy to report that Stratum has found its way into field trials and production. One of the big areas that this has happened is with the Aether network, which is an ONF platform or mobile edge compute platform. Canopus also earlier this year announced that they were entering trials and possibly some small scale production rollout with their Flow classifier application for telcos. And we've heard stories from other users as well. Hopefully they'll be able to share those with you later this year. We've also added support for the FPGA NICs in Stratum, which has enabled TASIN to some degree. TASIN is a BNG product that uses Stratum, and there are different flavors of targets that can be used. For example, using the FPGA NIC support that we have with Stratum, Dell, Intel, and Benu built a BNG server that stands in as the BNG data plane. And using Tofino, ONF and Intel have been working on a hybrid solution that uses Tofino as well as some FPGAs to fully realize the BNG. This past year, Stratum was also selected as the switch OS for the Pronto platform, which we'll talk about in the next slide. So just in case you haven't seen some of these, I want to just take a couple of minutes to dive in a little deeper to some of these use cases. So we can start with TASIN. So TASIN's a disaggregated BNG born from Deutsche Telekom's Access 4.0 platform. One of the ways that this is realized is through CUPS, or control and user plane separation, where we implement the control plane on commodity equipment and we implement the user plane on commodity switching gear. In TASIN, there's provided a logical abstraction that works on multiple targets. So FPGAs, ASICs from different vendors, et cetera. And the way that TASIN uses Stratum is that Stratum provides the user plane. So it provides fabric connectivity, IP connectivity, as well as some offloaded functionality that are part of the broader BNG, as well as a common control plane interface for the control plane that runs on that commodity server. And TASIN has needed Stratum because the pipeline that was chosen to define the BNG functions as well as the fabric was defined in P4. And Stratum provided a rich enough control plane interface that works across different targets so that the user plane or the control plane could be written once and the user plane could be realized in different modes. So shown pictorially, traditionally a BNG was a chassis-based box that you'd buy as pictured on the left. The transformation to SDN split the control plane and user plane, as I mentioned. And on the user plane side, there's different options. So there's Qumran-based box from DT. There's the SmartNIC project that I alluded to. There's a Tofino plus Qumran hybrid and Tofino plus FPGA hybrid. And the idea here is that Stratum is used to power the user plane. And we've seen on the right-hand side implementations where Stratum's already working. And there have been discussions about how we can bring Stratum to some of the boxes on the left-hand side. Moving on to Aether. Aether is a private 5G LTE edge access and compute platform targeted for enterprise. One of the cool things about Aether is it works with licensed spectrum. So it works well for telcos, and it also works with unlicensed spectrum, which is well suited for enterprise. And it works with CBRS, which is unlicensed spectrum that's been recently made available in the US that allows anyone to spin up a mobile access network. In Aether, we connect to the public cloud for subscriber management and configuration, and it enables Industry 4.0 applications such as real-time analytics, AI, ML offload to the cloud, as well as IoT applications. And Aether is already operational at more than 10 sites across the globe at ONF and some partners. Aether runs or uses Stratum in a couple of ways. First, Stratum runs as the switch OS in the Aether Edge pod, so it controls all the fabric switches, as well as the NIC OS for select FPGAs that are part of the user plane. And so in this particular role, Stratum's performing routing in the Edge pod using Trellis, and it's also offloading some of the user plane functions, for example, GTP, NCAP, and DCAP to the fabric itself. And Aether needed Stratum because the 5G LTE user plane brings unique data plane requirements that were typically realized using special hardware. So to bring those data plane elements to the fabric, we needed a really flexible solution. And beyond that, once we've had or embedded the functions into the data plane, we need fine-grained control over those functions and a high degree of visibility. This is control over forwarding QoS. We need statistics for accounting, et cetera. And using P4 runtime and GNMI, we were able to get the right degree of visibility for this particular platform. Taking a look at Aether pictorially, you can see that in the enterprise space or Industry 4.0 space, we have IoT devices, sensors, we have employees, visitors, robotics, et cetera. They're connected using the mobile network to radio antennas, which are connected to the Aether Edge fabric, which is co-located typically at the site. In this particular network, Stratum powers the fabric and provides an enhanced mobile user plane. And then control plane applications can either be located on site in the Edge fabric, or they can be located in the remote cloud. For more details on Aether, you can visit the etherproject.org page. Lastly, I want to talk about Pronto. So Pronto is a $30 million DARPA program that was recently created to build a 5G network with verifiable closed-loop control. The control plane applications and data plane extensions to realize this network are being built on top of the Aether platform in partnership with Cornell, Princeton, and Stanford. And the way that Pronto uses Stratum is that Stratum runs as a switch OS in the Pronto Edge fabric, as with Aether. And Stratum also helps participate in the verifiability and closed loop nature of the system by performing the fabric functions it does with Aether, along with exporting additional visibility via INT. And Pronto needs Stratum because part of the Pronto vision is to realize top-down full control of the data plane through a P4 specification of the pipeline. And that's something that Stratum provides. Stratum also provides sufficient visibility and control of network state to achieve the verifiable closed loop nature of the system we're striving to achieve. So to look at Pronto pictorially, the part of the vision here, is that we achieve closed loop control and verification, as you can see on the right. We export data plane telemetry that could be both INT data as well as network state to a verifier that can decide whether or not the high-level specification for the network is being realized. Feedback from the verifier can be passed down to the SDN controller, which can then reprogram or provision differences that are observed in actual network state. In the bottom here, we can see a picture that tries to demonstrate or realize the top-down programmable platform nature, where a high-level specification can be broke down into smaller specifications for each networking element, and then those can be pushed to both fabric switches, shown here in the middle, as well as smart NICs and software switches. So the goal here in Pronto is really to have a full control of the network and full visibility of the network from the process in which packets are emitted all the way across the fabric to the end user device that's receiving them. So hopefully that's been a quick tour. 2018, largely a building year, built a community, built an MVP. 2019 is where we showed what you can do with Stratum. And then we built on a lot of the successes and demos in 2019 this past year to try to bring some of these solutions to production. ONF has been working as a team to do this, and we've also been working with partners in the community. So I wanted to thank people in the community that have tried out Stratum so far, and I want to also invite those of you that see or have an interest in Stratum to try it out. So with that, I want to turn things over to Max, who's going to walk through some of the highlights and some of the new features that we've seen in Stratum over the past few releases.
Okay, great. Thank you, Brian. Hi all, I'm Maximilian Pudelko, member of the Stratum TST and developer on the Stratum project. And I'm going to talk to you about some of the features we did, some of the changes we did since the open source launch. Among these, the road to production worthiness, how we improve testing and usability. Okay, let's get started. Okay, so what do we do to address the production worthiness of Stratum? When using Stratum with production, we uncovered an amount of platform and interface shortcomings through that use. Among this, we figured out that there are missing features. For example, Stratum simply not take advantage of the whole API that was offered. In other cases, we just had poor platform support. For example, we relied on incomplete or unmaintained APIs for critical functions. And so how did we address that? In most cases, we could just replace shortcomings with better implementation and then accommodate these production uses. For example, on the Intel Tofino side, we replaced PI and the V1 model with the new Barefoot runtime and Tofino native architecture. On Broadcom, we replaced the SDKLT SDK with OpenNSA, much more battle-tested and mature SDK, which also allowed us to implement data plane features like MPLS and gave us access to more devices from the DNX and XGS Broadcom family of devices. On the platform support, we are currently in progress or working on replacing OMLP v2 and allowing to support the Tofino board support package, a very good platform for Tofino devices. And experimentally and opportunistically, we are looking into the Sonic platform API. This is a work in progress, so expect more changes here. Let's look into these a little bit more in detail. Oops. Brian, could you, I think I misclicked. One back. Okay, sorry about that, my bad. Let's talk about the Tofino native architecture and Barefoot runtime. When putting Stratum in production, the customers demanded pipeline flexibility. It's just not enough to just support V1 model. They often want Tofino native architecture and Barefoot runtime for its rich interface. So we accommodate this need by implementing a new target, which we call Stratum BF-RT, which lives alongside Stratum BF, our current implementation. So you now are presented with a choice. If you want to maximize portability with V1 model, which allows you to deploy to a multitude of platforms and a diverse set of these, you can stay with Stratum BF. But if you want to unlock the full capabilities of the Tofino hardware, then you can choose TNA and BF-RT, and Stratum will support that. That will give you, for example, access to registers, full control over metadata bridging, and more advanced features like pipeline folding or multi-pipe programs. On the platform side, we started the departure from ONL as the sole choice of base OS and platform API. There are several reasons for that. One of them is ONLP v2. Support is really just incomplete, sometimes not as good of it's quite buggy. The quality of the code is not that high. And on some devices, it's just not available. They're just not supported. On top of that, there's the unclear future of the ONL project. Its core sponsor has dropped out recently, so we're not sure if we want to build on that project anymore. And lastly, there's often a conflict with mandating ONL and the heterogeneous deployment reality that we see at customer sites. they, for example, want to have Ubuntu images or Neo Debian images. In some cases, they even have their own custom image that they don't want to give up. So we accommodate this again by implementing a new platform plugin model that allows choosing the best available or just the most suitable implementation for production use. OwnLP remains as a supported plugin, but we added more. For example, we now support the transponder abstraction interface, short TAI, which allows controlling long-range transponders, like for example in the Cassini boxes. On Tofino, we are exploring supporting the Tofino board support package, a very mature and well-supported API on these Tofino devices. And like I said, Sonic is also on the roadmap. Okay. Let's go talk about testing. We figured out that we need a comprehensive testing, certification, and deployment lifecycle. It has to be holistic. It has to cover all aspects. So we started with adding unit testing guidelines for new code and improving the test coverage for existing code. This means if today new code is added to the code base, it has to be accompanied by a unit test. And this unit test has to be run by CI. So it's completely automatic and it is enforced. Taking it one step further, we now enabled integration testing on software switches beyond what we already supported with BMB2. So this means with a Tofino model, you can now test TNA pipelines as well as your V1 model pipelines. The idea here is that you should be able to test what you deploy. So your testing setup should not be different from your production setup. Then next, we started the continuous certification programs, which is certification for the CI era. If you're interested in that, we have more on that on our website. But the gist here is these are nightly hardware tests that are picking the newest code from master and run it on actual hardware devices using Jenkins pipelines. This whole thing is powered by test vectors, which is our Stratum's black box test suite that we developed. Lastly, we created Stratum Replay, which allows you to capture and replay production traces in a development environment. The idea here is that if you uncover a data plane bug, you take these log files and traces and give them to your developers, and they are able to reproduce the problem and hopefully solve it. Additionally, you can prevent regressions by adding these same traces to your integration tests and maintain a good stability for the future. Okay, how did we improve usability? When we first open sourced Stratum, there was a severe usability problem. There was a lot of tribal knowledge required, and you really had to be a core member of the development team to really be able to deploy Stratum. There was a lot of manual setup involved, installing dependencies, moving files to the correct places. Wasn't really good, to be honest. There were also inconsistencies between the Tofino and the Broadcom targets. That meant that even if you mastered one of them and finally figured out how to do it, it didn't transfer over to the other one. So you had to start anew, which is not a good experience. So what do we do here to make this Stratum deployable by non-developers? First of all, we provide universal binaries now and not an explosion of options to choose from. For example, we now have complete packages in case of Debian, if you prefer, or Docker images if you want to go with these. These are industry standard practice and are just one-stop solutions. They basically install themselves. You don't have to know how they work. You can just do it. These packages are also stamped and labeled with build information, so you always know which version you're deploying and how old it is. We enhanced the documentation, of course. So we added configuration and runtime and troubleshooting sections about common problems that occur. Whenever we see a problem or are reported an issue, and we are able to solve it. And if we think that's a common thing, we just add a new entry to the section so that the next person that has this problem will not have to go through the process again and can just depend on existing documentation. We also removed a lot of redundant sections by automating a lot of stuff. In general, we improved the user experience by just doing the right thing by default and removing a lot of the command line flags, which were just noise in the end. Then we automated whatever was feasible. For example, today you can do a git checkout and get a complete build Debian package file in a single command. And that's pretty powerful. Again, next step would be streamlining the pipeline format, which we did on Tofino. We went from an implicit arcane binary packaging format to a standardized protobuf here. On top of that, we also include tooling that bridges the gap between the compiler output and what you actually have to give to Stratum. So you're not sitting there just packing this stuff manually. You will have a tool that takes whatever the compiler gives you and what we expect inside Stratum. So you basically don't have to know how it works. You can just apply the tool. We simplified the configuration files, often by just hiding irrelevant system internals, like, for example, the SDK port numbers from the configuration file. We just figure them out on our own inside Stratum. You don't have to know about them. They don't really offer you anything. In summary, all these changes empower us today to where we are, and that is today inside Stratum, inside ONF, Stratum is deployed by a team that is separate from the development team. So we managed to separate that and increase the usability to a level where this is possible now. Okay. Let's talk about our release strategy a bit. We had our first open source release in September 2019, like Brian said before. And we will continue our live at head philosophy. That means there are no LTS branches or LTS baggage that we have to carry around. We don't do feature backports or semantic versioning. This allows us and the development team to be very fast moving because this is a lightweight process. But if you're looking for deployment and want to have a little bit more stability in this, we still offer quarterly qualified and tested releases. So we had 3 of these so far, and we're doing the next one in March 2021, which is our next planned release. So how does this look? You might hear no LTS and no semantic versioning. That might sound a little bit crazy to you. So how do we handle breaking changes? Sure, let me explain that. And we borrowed this context, sorry, we borrowed this. We didn't invent this practice. We borrowed this from the cloud computing community. And what we do is we do non-atomic refactoring with continuous deployments. And if you want to look for examples of that, you can look at the Upside project, Bazel, or Protobufs, which have been doing this for years very successfully. Let's go through an example. Let's say we are currently on release N, and that contains an old feature, or a current feature to be exact, that you depend on. So that's the feature, that's the release you currently pick. We are adding a new feature at the current head of the master branch. While we're doing this, we would discuss the changes we made in TST meetings and directly on the pull request itself. So the community is welcome to chime in and shape the future here. At the same time, we will ensure that there are no breaking changes to the old features. So we will only do additive changes here. Sometimes this means we have to introduce a new target and keep it in parallel with the old one. We will, of course, include tools and documentation for an assisted migration. So in the future, when the time finally comes around, you will not be left alone. We will clearly mark the old functionality as deprecated at this point, but it will still be in there. It will still work. Our next quarter release will come around, in this case, N+1, and the new feature is included and officially released. At this point, if you pick this release, the old and new feature will be available at the same time. But the old one, like I said, is deprecated. So you can expect to see logging messages encouraging you to upgrade or migrate. After another 3 months, the next release after that, so N+2, will remove the old feature, and now it's the time where you have to migrate. You have to use the new feature because it is finally removed. I hope this clears it up a little bit and doesn't make you too anxious about our release strategy. Okay, let's see what new platforms and ASICs we added. As you can see, the list is quite extensive at this point, and everything in green is what we added since 2019. I think I can highlight 2 boxes here. That is the Cassini, the long-range transponder Brian talked about, and we continue to add more barefoot devices like the Edge Core Wedge 100BF QS. For an up-to-date listing, you can follow this link at the bottom and yeah, see an up-to-date list of that. Okay, and with that, I will hand it back to Brian, who will talk to you about the roadmap for the coming year.
Awesome. Thanks, Max, for taking us through some of those details. So looking forward to 2021, I think it's easiest to think about three themes that we're planning to make progress on for Stratum. So the first theme is we want to continue to support production users. So we've heard a number of requests and features, and we're trying to respond to those and prioritize them as well. One big area that we're currently making good progress on is QoS. So we've been enhancing our support for the QoS model that's already defined in OpenConfig, as well as currently looking at bringing in some extensions to the QoS model that'll support hierarchical QoS for the NIC. On the Tofino side, we've been, and we're currently working on enhancing our support for controlling the scheduler and traffic manager. This way, when we map ports or packets to queues, we can control those queues and their behavior. Externally, we're continuing to make enhancements to the APIs, the public-facing APIs like P4 Runtime, GNMI, and our gRPC version. So there are some features and gaps that we're looking to fill, for example, in P4 Runtime, like adding support for watch ports, and also tweaking and updating the way we do mastership arbitration and potentially role management later in the year. On the testing side, we're looking to improve the CI system, and we've had some bugs and issues just in CI performance. So we're looking to make that a bit more stable, as well as adding pre-merge hardware validation. This means running code on hardware when it's just a pull request before it's merged to master and gets picked up by the continuous certification program. So that's supporting production users. The second theme is portability. So in this particular theme, what we're looking to do is standardize configuration. So if you've used Stratum before, you probably had to write a chassis config to get Stratum started. We're looking to move away from chassis config as a user-facing API and move to the more standard open config models. Tools are also going to be forthcoming for that. Max talked about some of the changes we made on the platform API side, namely converting our platform integration to a plugin model where we can support other APIs other than ONLP. So our focus here is really just on transceivers and ASICs for new plugins. We may not need to control things like fans and power supplies if there's some other process on the box that's already doing that. But we have a good path forward for doing the BSP first, and then also exploring Sonic a little bit later this year. And lastly, we want to test and run Stratum on other switch OSs. So by default, we encourage users to use ONL today, but we recognize and realize others want to use other OSs. That's totally fine. So we're looking to maybe test on Sonic-based images or Ubuntu Debian images later as well. And lastly, we want to continue to make improvements usability-wise. Documentation has come a long way, but it can always be improved. We're looking to add additional sections that cover some gaps today. We also recently added support for Tofino model, but we're continuing to work with the community to improve Tofino model usability. Currently, there are some community contributors working on an integration that brings Tofino model to Mininet, as well as makes it easier to link the P4 program to Tofino model for easier debugging. And lastly, we just want to continue to improve build and release automation. So releases are still somewhat manual. If we make those lighter weight, we can do them more quickly. And on the build side, we're exploring using Bazel to build the Docker containers to simplify that process for users. So that's largely the technical roadmap. Support production users, increase our portability story, and continue to make the platform more usable. Taking a step back, I just wanted to look at one other thing that's potentially looming on the roadmap. And one of the questions we get asked a lot is, how does Stratum compare to Sonic? What's the story there? And to adequately compare Sonic and Stratum, you have to realize that they're solving two slightly different problems. As I mentioned before, Stratum's a thin switch OS, which means you have to bring a control plane. So it's a more fair comparison to compare Stratum and Sonic's data plane. Stratum bringing a data plane and Sonic bringing a data plane of its own, which is SI. So on the SI side, or switch abstraction interface side, there's a vendor-independent switch interface. It provides common fixed function logical ASIC pipeline, which is really well suited for data centers. It covers a lot of L2 and L3 capabilities. And they've provided a common API and pipeline that allows you to develop and integrate common control plane components. For example, like you can bring a routing engine like FRR and write it once, and it runs across all targets because the pipeline and the routing definition is all the same. However, there are some downsides to this that we've seen as well. For example, changes to SI require community consensus, which can take a really long time, months, maybe even years. And then once those changes are accepted, you require or have to wait for your vendor to support the new features. It means that vendor-specific functions get exposed through private extensions, and these extensions get maintained pairwise between vendors and customers. So it's a bit of a burden for customers who have to wait for these extensions from vendors, and vendors have to support different extensions for different customers. And then lastly, SI is designed, because it's a C API, around a control plane that lives on the box. So it's not super well suited for SDN. In contrast, Stratum is also a vendor-independent switch interface, although at a different level of abstraction. In Stratum, the data plane is fully user programmable using P4, and vendors can expose their vendor-specific secret sauce through a P4 interface to users. And Tofino native architecture, or TNA, which Max described before, is a perfect example of vendor-specific functionality getting exposed through a programmatic common interface. Stratum also supports on-the-box traditional control planes as well as SDN-style control planes. And so it's been well suited for users that are looking for SDN. On the downsides, potentially, Stratum requires that there be P4 support for your targets. So if you don't have P4 support, you're kind of out of luck. And the other thing is the bring your own pipeline is a blessing for some users and a curse for others. No common pipeline means that control plane components need to be pipeline specific. And that means that when you go from one pipeline to another, oftentimes you need to change your control plane components. We've made some efforts in ONOS to help smooth this difference between data planes, although it still has some downsides. So one of the things we've been looking at is, are there ways to get the benefits of both sides? And a project that we've started to look at ONF is a way that we can explore adding some new features to Sonic. And this is a program we call PINs, or P4 Integrated Network Stack. So in PINs, you get SI. So you get that common logical L2, L3 pipeline that's well suited for data center use cases. There's a common abstraction which allows for common control plane components, and we still have vendor independence. But from the Stratum side, what we're pulling in is user extensibility of the SI pipeline using P4 for supported targets. And we're also allowing vendors to export more easily some of their secret sauce if their target supports it as well. We're also bringing a P4 runtime interface to Sonic, which allows for SDN-style control plane of both the traditional Sonic components as well as the P4 extensions. One caveat I just want to highlight here, and it's the crossed out part here, is that in Stratum, as we mentioned, you bring your own pipeline. You fully define it yourself, which means you can have complete control over how it's defined. In PINs and in Sonic, the base abstraction is SI. And what you do is you extend SI. And so one way to think about the differences between perhaps the PINs project and Stratum project is PIN starts with a common SI pipeline and allows you to extend that, whereas Sonic allows you to start from scratch, or sorry, Stratum allows you to start from scratch and fully define that pipeline for yourself. So taking a step back, looking at the bigger picture, Stratum is really great for users that want or need to fully customize their pipeline. And a lot of the use cases that we've talked about today and a lot of the use cases that we continue to hear continue to fall into this bucket. Like I want to write I'm a P4 expert. I want to write my P4 program and my use case depends on it. I need access to all these features. And I care deeply about controlling how the stages in the ASICs are being used. So for those users, Stratum's a good choice. And what we're trying to do, as I mentioned before, is continue to support Stratum in production for those users, including Aether project and the Pronto deployments. We're trying to play to Stratum's strengths by continuing to enhance programmability. And we're trying to make Stratum a complementary option for any switch OS by improving interoperability, portability, and platform integrations. One thing that may be helpful is to think of Stratum in these other OSs as just an application that provides a rich programmable interface to the data plane that can run anywhere. As an application, it's a complementary piece to any NOS, or can be a complementary to any NOS, and doesn't necessarily need to be viewed as a full stack competitor to those. So with that, before we close, I just wanted to give those of you still on the call a few action items. The first is, if you're using Stratum, please take a moment to take the Stratum user survey. It's a survey we just put out this month, which is helping us to gather feedback from users about how they're using Stratum and where they're finding issues. So if you want to help us shape our priorities in the future of Stratum, please take that out. Or please take a look at that. It should only take about a minute. And then if you want to get involved in the project, we'd welcome you to join our TST calls. Those happen weekly on Thursdays. Join our Slack channel, and then also join the mailing lists. Details for the calendar as well as how to join Slack and the mailing lists are in this link here. If you're just getting started or you're new to the community and you wanna play with Stratum, the NG or Next Gen SDN tutorial is a fantastic starting point. It may take a day or a few to work through it all, but you're going to really be an expert at Stratum and some of the interfaces that we expose at the end of the tutorial. And lastly, if you're already a member of the community, we'd encourage you to send PRs. And to those of you that have sent us PRs and are working on things and sent us bug reports, we really appreciate that. So with that, just wanted to thank you for attending. Here's a link to the ONF Stratum page as well as the GitHub if you'd like. And I think we have some time for questions. All right. So Max, I'd invite you to come back and help answer these questions if you'd like.
Of course.
All right, so maybe the first one that I see here is a question from Hemant, which says, whose or what partition tool do you use? And I think what is being referred to here is the partition tool in the Pronto story. So this is a tool which is not yet been developed as I understand it. It's work that is being done by some of the university partners, Cornell and Princeton. And so I would encourage you to take a look at the Pronto project website and follow that project to see where that's coming from. All right. So I guess the next question is also from Hemant. Any plans to talk to Cisco to support Silicon One in Stratum? So in terms of Silicon One support in Stratum, we haven't really seen much interest in Cisco in doing that. But I will say that Cisco is involved in the PINs platform, and we may see some programmability exposed to Silicon One on a pin switch in the near future. How does TASIN compare to open BNG. So this question comes from Sergio. I'm going to be honest. I'm not a big expert in the use case. Just have been more involved in how the use case has been realized on the Stratum platform. So I'd encourage you to reach out to the Tassen community, and they may be able to help help you there. If you want a link to the project, here's a GitHub link here. Carmelo Cascone at ONF would be a really good resource, or if you know Craig Stevens or Mario Kind, they're leading the project. They've also done a number of talks in the past, and I'd encourage you to look at those. Maybe we can find a link. But if you go to the ONF events page and look through past events, you may see a talk on Tassen, or just Google Tassen Open Networking, and you'll probably find it. All right. There's a question about slides. When will the slides for the webinar be available? Right after the webinar, the great team of Michelle and Denise are going to work on getting the videos compiled, and we'll give them the PDF of the slides, which will be distributed with the link. So hopefully we can send those to participants. So if you registered for the webinar, check your email, and in the next day or two, hopefully we'll get you the slides. There's a question here from Michael mentioning support for Debian, and there's a question about support for Yocto. Do you want to take this one, Max?
I can take the Debian part, but Yocto, probably better if you cover it.
Sure.
So let me start this from different ways. When we say support for Debian, Stratum itself doesn't have that many dependencies on the actual operating system. We package it in a way that most dependencies are statically compiled and just in there. What we really only need is often access to the ASIC, to the chip, data plane chip in some form, and some basic functionality from the Linux operating system. That's pretty much all we need. So if we want to talk about support for Yocto, guess it all depends on the platform API, right, Brian?
Yes. So I think maybe this question is coming from there's a new Linux Foundation project called Network Grade Linux, which is it's being positioned potentially as a successor to Open Network Linux. And instead of being Debian based, it's Yocto based. I think in that particular project, there is a desire to use the Open Network Linux Platform API, or ONLP Platform API. So yeah, from our perspective, we have Bazel, which generates a binary. We can pack that up into a format that that Yocto is happy with, and then as long as we have access to a platform API at runtime via like a shared library, we should be good to go. Yeah, our dependence, yeah, is quite minimal. And actually, if you look at our software switches like BMB2, BMB2 run on any flavor of Linux. So yeah, there's not an explicit dependency on Linux. We may need to add some additional packaging, but Yocto should be an easy thing for us to support. All right. So there's a question from Alex. Do you plan to certify new OSs via the CCP for Stratum? So the continuous certification program aims to certify Stratum running on a box, and maybe what we can do is for each individual box, we can allow vendors to specify a default. So a default OS, that is. So right now, the default is kind of ONL across the platform, but we could allow for example, like APS network switches to be network grade Linux based or Ubuntu based, if that's a preference. So, I mean, from our perspective, there's no real dependence on the base OS, and so I think that's definitely something we could be open to. All right, so there's a question from Lida. We're planning to look into it for our platform, which is SmartNIC based, but unfortunately not all of our SmartNICs support P4. So that's, I guess, that's unfortunately kind of a prerequisite in Stratum. The idea is that the pipeline is defined in P4. Now, one thing I can mention though is that we have seen a couple of different techniques be used to support P4 across different targets where there is not necessarily a compiler. So one option is for Broadcom targets, for example, there wasn't a P4 compiler, and for example, like the Tomahawk ASIC is a fairly fixed ASIC in terms of its capabilities. And so one of the things that we have there is what's called a fixed pipeline mapper. In the Stratum code, it's FPM, the FPM compiler. But what we do is we start with a Broadcom ASIC feature. We figured out how we want to model it in P4. And then we have a compiler that maps the P4 code that's been written by a user to the P4 entities that we've already devised the mapping for. Max has a great talk on how we do this and how we add new features to it. So that's one possibility if you want to kind of do this semi-automated approach, is do something like fixed pipeline mapper. Figure out how you want to model parts of your NIC in P4, and then have a compiler do the mapping for you. We've also seen people do manual mappings. For example, if there was a particular P4 program or pipeline, say you wanted to start with the PSI pipeline, or say you wanted to start with the TASIN BNG pipeline, and you wanted to map that to your NIC, one thing you could do is you could just have an engineer manually write the integration or manually write the mapping between the P4 program and your API. And that's a fine way to get started. When the number of P4 programs you want to support is low, it's pretty easy. It maybe gives your engineering team an opportunity to understand the details of how P4 works and what the entities look like, and could be the basis for a semi-automated or a full backend in the future if you're finding that there's value for your customers. So hopefully that answered the question, but if you want to follow up, feel free to do that. Moving on. Serdar asks for the difference between using Stratum on Tofino compared to BF runtime directly. And this is a great question. And it comes down to, I think, sort of portability of your client in the future. So, if you want to use BF runtime, and the only platform you plan on supporting is the Tofino platform, then like doing that integration might make sense. And we've talked to a lot of users that prefer to just use the BFRT directly. One thing I will say though is that if in the future you want your client to be portable across other vendor ASICs, using a community standard interface like P4 runtime and GNMI to control things like the pipeline stages and the traffic manager may give you some degree of flexibility to move your solution across different platforms. If you wanted to get sort of the best of both worlds, so to speak, some users in the Stratum community have actually run a BF runtime server and Stratum together in the same process. And what that allows you to do is do things that you can do in P4 runtime using the community standardized API in that way, And then for just the exception cases that maybe aren't covered in P4 runtime yet, do those using BF runtime. So I would say, just to summarize the benefit, Stratum APIs are community driven. They're supported by multiple vendors, and they're more likely to be reusable in the future. Whereas BF runtime is a proprietary interface exposed by a single vendor. So you just have to be aware of potential lock-in. All right. Shiv had a question. Is there any simulator like Mininet for Stratum? Yes, I will say there is. So we haven't put Stratum into upstream Mininet, but we have created a custom file that allows you to access or use Mininet to control a network of Stratum devices. So actually, in the NGSDN tutorial, the link that I provided on the next slide, in here, you actually will use BMV2 with Stratum running on it, controlled by a Mininet network. And as I mentioned before, in the technical roadmap, there's actually some community members that are working today on getting Mininet support for Tofino model as well. So you can run Stratum plus BMV2 or Stratum plus Tofino model in a Mininet orchestrated network. And at ONF, we use Stratum BMV2 and Mininet extensively in our testing and development. So hopefully that answers that. There's another question from Hemont. I suspect P4 to support. I suspect P4 to FPGA support just to synthesize an NPU on FPGA. So it shouldn't be that hard to build a P4 compiler to FPGA. Yeah, I guess I'm not totally certain in kind of the lower level details here, and I think there's going to be some specifics that are dependent on different platforms. But I know that there have been a number of efforts. Netcope most recently had their P4 to FPGA compiler acquired by Intel. Xilinx also has a toolchain that they've used. So there's been work that's been done both in the commercial space as well as in the open source space to do this type of synthesis. So yeah, for those of you that are looking to do or add P4 support to FPGA, there's certainly prior work that can potentially be used. Okay, so again, check your email. We'll be happy to distribute the slides as well as a video recording of the webinar. Thank you for attending, and thanks to Max for helping to present. So with that,
thanks for
hope
giving
you
me the
enjoy the rest
opportunity.
of your day, and we'll talk to you later.